Looking at the sum and difference identities, you're going to notice that we are doing more um, practice problems with taking sine, cosine, tangent, and finding new ways that we can work with them, finding new ways that we can express them, finding new ways of which we might even be able to find exact answers out of certain cosine values or sine values, maybe even finding out ways that we can manipulate our right triangle, so that we can get an answer out of something, that out of information that we have that we might not think is entirely enough. We might have to manipulate a few things, change a few things, and now suddenly we find that we're actually moving in the right direction. Sum and difference identities can help us with these particular problems. This figure is a figure that you're going to have somewhere. You really only need the 0 to 90 degrees because the rest of them you can make. I mean, it's simple enough to realize that for 30 degrees, you have square root of 3 over 2 for cosine and 1/2. 45 is square root of 2 over 2 for both, and then 60 degrees is 1/2 square root of 3 over 2, and then 0, 1. We know this because pi over 3 is just a reference angle, or 2 pi over 3 can just be the reference angle for pi over 3, which is right here. But we recognize that because cosine is now in the third or the second quadrant, that it's now negative. And we can do that for the whole circle. But this circle itself, these values you should have written down or have at least memorized, at least these 5 values here, because we're going to be going back to them frequently. Now, the first thing we're going to show here is I'm going to skip all of the proof. We don't really need to know how this is proven. We just need to know how they work. So if I have two angles, alpha and beta, and I add them together, and I want to say cosine of angle alpha plus beta, I can actually say that that's also cosine alpha times cosine beta minus sine alpha times sine beta. Now, here's the thing. I could get just the cosine of alpha plus beta. So let's say, for example, that I'm looking at the cosine. Let me write this down for you. I'm looking at the cosine of, see if I can get my, if I have cosine, good pen here. Here we go. Cosine of 75. I can actually rewrite this as cosine of 30 plus 45. And I have exact answers for both of these. I have exact answers for the cosine of 30, which is cosine of alpha. And I have exact answers for the cosine of 45, which is, again, cosine beta. I have exact answers for those because this diagram shows me that I have exact answers for those. And I can use this particular formula right here to get what the exact answer of cosine of 75 degrees is. Now, I don't have an exact answer on my circle to give me what that exact, I don't have any way of getting the degree 75 on the circle. There is no 75 degrees on the circle. It's going to be between 60 and 90. But if I were to split them, let's say into cosine 30 plus 45, I can actually get that exact answer by using this formula. And so let's go ahead and use this formula just as an example. So we need to recognize what cosine 30 is, and we need to recognize what cosine 45 is. We need to know what sine of 30 is, and we need to know what sine of 45 is. And we can look all of those up in the circle. And I'm going to quickly just kind of use a reference that I have over here. So cosine of 30 is the square root of 3 over 2. The cosine of 45 is the square root of 2 over 2. The sine of 30 is 1/2, and the sine of 45 is the square root of 2 over 2. And if I were to use this formula that we see down here, cosine alpha, which is the square root of 3 over 2, times the cosine of beta, which is the square root of 2 over 2, and I were to subtract that from the sine of alpha, which is 1/2, times the sine of beta, which is the square root of 2 over 2, and I were to simplify that, it's going to be the square root of 6 over 4 minus the square root of 2 over 4. This is equal to the square root of 6 minus the square root of 2 over 4. And this is the exact answer for what cosine of 75 degrees is. So if I were to ask you the exact answer for cosine of 75, even though it doesn't appear on this unit circle that's right here, you could still give me the answer by splitting 75 into 45 plus 30. You could also split it into, let's say, 120. What would be a good 75? Yeah, 120 minus 45 could do it as well. You could split it into 120 minus 45. And if you were to do that, you would have to use this cosine formula in order to make that happen. I could also do the same thing with sine. What is the sine of 75 degrees? And there are formulas for that as well. So let's practice this just a couple more times to make sure that we actually have it. Let's say, for example, that I'm trying to find the value of cosine 5 pi divided by 4 minus pi over 6. Now, here's the rub. Here's the thing. Cosine of 5 pi over 4 minus pi over 6 is the same if I were to subtract these two from each other. And I'm not quite too sure what that would be. I'd have to make sure that these are equal to each other. I would have to multiply this by 3. So that's 15 pi over 12. And I would multiply this by 2. So that's 2 pi over 12. And so this would be 13 pi over 12. That is actually what I'm trying to find. I'm trying to find the cosine of 13 pi over 12. But do you see that anywhere in the circle? No, there is no cosine of 13 pi over 12. But there is, if I were to split this into 5 pi over 4, well, that's right here, and into pi over 6, that's right here. I have exact answers for 5 pi over 4, and I have exact answers for pi over 6. So I can go ahead and use this formula up here in order to actually get the cosine of 13 pi over 12. And so I write down a few pieces of information. I need to know what the cosine of 5 pi over 4 is. I need to know what the cosine of pi over 6 is. I need to know what the sine of 5 pi over 4 is. And I need to know what the sine of pi over 6 is. And I use that same circle that I have here. And the cosine of 5 pi over 4 is negative square root of 2 over 2. The cosine of pi over 6 is the square root of 3 over 2. The sine of 5 pi over 4 is the negative square root of 2 over 2. And pi over 6, the sine of that is 1/2. So I have exact answers for each of those. And I use this formula for cosine, subtracting this time. So I'm going to go ahead and use this formula right here. The cosine of alpha, which is this value here, negative square root of 2 over 2. Cosine of beta, that's this value over here. So that's going to be multiplied by the square root of 3 over 2. That's going to be added to the sine of alpha, that's this right here, negative square root of 2 over 2. That's going to be multiplied into this sine beta, which is pi over 6. That's 1/2. I simplify. That's negative square root of 6 over 4 minus negative square root of 2 over 4. And so that's going to be equal to negative square root of 6 minus negative square root of 2 over 4. If we were to show the solution, that's exactly the solution that we have. How do we break this up? Again, I need to break up the square root of 13 pi over 2 into two angles. Those angles are alpha and beta. And I split them up into 5 pi over 4. That's my alpha. This is my alpha angle. And this pi over 6, this is my beta angle. I split them up into those two. And then I look for exact answers for that alpha angle, cosine 5 pi over 4, cosine pi over 6 for my beta value, sine pi over 4, 5 pi over 4 for my alpha angle, and sine pi over 6 for my beta angle. Plug them into this formula, and then just simplified. And that was all I had to do. For OpenStax, I'm not going to put this into the lecture or anything like that. Go ahead and see if you can find the exact value of this using this formula. And go ahead and add these two together and then put that into your calculator and see whether or not that the answer that you got matches the answer of this particular, when you added them together and then put that into your calculator. If they match, you've done it right. Okay, we've already discussed if I were to find the exact value of an angle that's not appearing here, if it's possible for me to split it into two, then I can find an exact value. I'm not going to be able to do that for all instances. Just for certain instances, I'm able to split them up and get an exact value. I can do the same thing with sine. And I don't think I need to do an example here. I just need to show you because it's going to work in exactly the same way. Sine of alpha plus beta is going to be equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. That is exactly the same value as if I were to add the angles alpha and beta together and then just find the sine of that value. But in order for me to do that, if it's not on the circle, I need to use a calculator. But what if you're forced to find an exact answer? Then I need to split them up. And if I can split them up, then I can give you an exact answer. If I can't split them up into anything that's on the circle, then there's no way for me to give you an exact answer without using a calculator. So we are hoping that when we have an angle that I am able to split things up, and I am able to use this circle to find exact answers of those two angles that I have designated. If I'm going to add two angles together to get that one angle that we're looking for, or if I'm subtracting two angles to get that one angle that I'm looking for. If I can do that, then I can give you an exact answer. If not, I'm going to have to use a calculator. Okay, so again, if I have the sine of 45 minus 30 degrees, 45 is my alpha angle, 30 is my beta angle. I am subtracting them, so I have to use the second one. I find the sine of my alpha, which is 45. I find the cosine of my beta, which is 30. I'm going to subtract that from finding the cosine of my alpha, which is 45, and the sine of beta, which is 30. So sine 45 times the sine or cosine of 30 minus cosine of 45 times sine of 30. Once you get those answers, you simplify and you will get the correct exact answer, as we see here. The sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. I'm doing the same thing here on my tablet. Cosine of 45 is square root of 2 over 2, and sine of 30 is 1/2. I plug them into the formula. That's what you see right here. Things are being plugged into this formula right here. And then I simply simplify everything, and I'm left with the square root of 6 minus the square root of 2. All of that divided by 4. And I can do the same thing here if I'm subtracting these two angles. I will do the exact same thing. I will find the sine of the alpha and cosine of beta, cosine of alpha, cosine of beta. I will plug them into the formula, and then I will simplify. Now we have this one example that's right here, and we might find ourselves with this kind of a problem. So how am I to move forward in this? Well, again, we said that we're finding the sine of a alpha value plus the sine of a beta value. What is my alpha value? Well, my alpha value is the cosine, inverse cosine of 1/2. What does it mean to be an inverse cosine? It means that I'm getting an angle. So that makes sense. Alpha being an angle, inverse cosine giving me that actual angle. Well, what is that angle? Well, whatever the cosine of 1/2 is going to produce for me as an angle, well, that's going to be 60 degrees. But here's the thing. I am looking for, therefore, the cosine of 60 degrees. Well, what is the cosine of 60 degrees? Exact answer, 1/2. So this value, inverse cosine of 1 over 2, is just 1 over 2. I found my exact answer here. Plus, so the cosine of alpha is simply 1 over 2. So cosine of alpha, which is 60 degrees, is 1/2. So cosine of 60 is 1/2. And then this value here, this sine value, again, as you see here, if I'm looking for the angle, I don't need the angle, I just need what the exact answer is. The exact answer for this beta is 3/5. That's the exact answer that I'm going to get back. The cosine of this angle that I get returned. That's what I'm looking for. Now, how am I supposed to find the sine of this angle? I have cosine alpha. We've already found cosine alpha. Cosine alpha is 1/2. I have found sine beta. Sine beta is 3/5. I know those two answers. I know them because that's how inverse cosine and inverse sine works. I have exact answers for those. So then how in the world am I supposed to find cosine beta? And how am I supposed to find sine alpha? Can't get them from this information, or can I? Well, I'm going to have to use something that we use frequently if I have something in cosine, and I need to get an equivalent answer in sine. Remember, we have sine squared alpha plus cosine squared alpha is equal to 1. And if I have at least one of these, I can get the other. Well, I do have one of these. I have 1/2 for this value right here. So sine squared alpha plus 1/2 squared. Well, that's sine squared theta, I'm sorry, theta, not alpha, is equal to 1 minus 1/4. Well, because this is 1/4, and I subtract 1/4 from both sides, this is going to be equal to 3/4. And I take the square root of both sides, and this is going to be the square root of 3/2. So this answer, cosine for alpha, I'm sorry, whoops, I'm looking for the sine. So sine alpha is square root of 3/2. There we go. This one is the value that I looked for by plugging in this alpha value. So I need to do the exact same thing here by using the same Pythagorean theorem. So I'm going to do it over on this side over here. So now I know the sine value, so 3/5 squared plus cosine squared theta equals 1. So I'm going to find this value through this value. So that's going to be cosine squared theta is equal to 1 minus 9/25. That's 16/25. That's, if I take the square root of both sides, that's going to be 4/5 cosine. So this value here is 4/5. And now I have everything that I need to solve my problem. I have all of these values right here, and that's going to be enough for me to solve. And all I need is now the formula. What's the formula that I need to use? Well, I need to know what was the problem, what's the original problem asking? A sine of two angles being added together, okay? That is this one. Sine alpha, so square root of 3/2. Let me erase this so that just makes it easier for me to show you down here how to write this out. So sine alpha is right here, negative square root of 3/2. That should be an equal sign. Times cosine beta, that is 4/5. And that's going to be added to, because it's alpha plus beta. Cosine alpha, which is 1/2, times sine beta, which is 3/5. So that is 4 times the square root of 3/10 plus 3/10. So that's 4 times the square root of 3 plus 3/10. And if we were to look at the answer that they gave us, that is in fact the answer that they have for that solution. Again, how did they find this out? Because the inverse cosine is an angle, and I need the exact value of that angle. That's what we've been doing. We're trying to find the exact value of angle 45. Well, what is the angle of 1/2? I get that through the inverse cosine. I'm going to do it. So once I get that angle, I need to get that exact value, and I will look that up on my wheel. Well, as it turns out, that if I'm looking for an exact value of an inverse, if I'm trying to find the exact value of an angle, and I've already done an inverse cosine of that exact value, 1/2 is the value that I'm looking for. That's just a property of inverse cosine. So I've already found my cosine for alpha. It's 1/2. And I've already found, therefore, my value for sine beta. That's 3 over 5. Problem is I don't have a value for sine beta, for cosine beta, and I don't have a value for sine alpha. And so I need to use the Pythagorean identities to get both of those. And that's how I solve that. So if you find that you have a question that's in this formula, this is the method which you need to use. And if you find yourself, you have both a cosine alpha and a sine beta, but you don't have the cosine beta and sine theta, or vice versa, you will need to use the Pythagorean identity to get those values. There's tangent. So these are the sum of difference formulas for tangent. So if I'm adding, say, for example, pi over 6 plus pi over 4, I need to look up the values for tangent of pi over 6. Those are actually easy enough to do. The tangent value for pi over 6 is right here. We simply take the sine 1/2 and divide it by the cosine, which is square root of 3. So that's actually equal to 1 divided by the square root of 3, which in this case is going to be the square root of 3 over 3. That should be part of, 1 over square root of 3, but they're not going to change that. And then the tangent of, so we'll just leave it like that for now. I mean, that we should rewrite it as a square root of 3 over 3, but they didn't change it, so we'll just leave it like that. Tan of pi over 4 is equal to 1 because the sine of square root of 2 over 2 divided by the cosine of square root of 2 over 2 is 1. Once I have these two values, I will plug them in. The tan of alpha we discovered is 1 over square root of 3. The tan of beta we discovered is 1, so 1 over the square root of 3 plus 1. All of that divided by 1 minus, well, the tan of alpha was 1 over square root of 3 times the tan of beta is 1. So that's what we have written right here. I'm going to blow that up so you guys can see it. And then I will simplify this into 1 plus square root of 3 over 3, divided by square root of 3 minus 1, divided by square root of 3. It will all eventually simplify into the square root of 3 plus 1 divided by the square root of 3 minus 1 using properties of radicals. Again, nothing really fancy here. I need to know what the angle of the tangent of alpha is, which we wrote. I need to know what the tangent of beta is, which we wrote. And then I plug into this formula to get an exact answer of what pi over 6 plus pi over 4 would have been if I added those two together and found the tangent of that value using a calculator. So we can do the same thing here. Find the tangent of 2 pi over 3 plus pi over 4. Well, what is the tangent of alpha? It's right here, square root of 3 over 2 over negative 1/2. That's going to be the negative square root of 3. So tan of alpha is negative square root of 3. Of course, we have to make sure that we are within our our range, our domain. We need to be in the correct domain. What is the domain of tan that we should be using? Are we using inverse functions? No, we're not using inverse functions, so I don't need to worry about the domain. If I'm worrying about the domain, it's because I'm worrying about inverse functions. No inverse functions are being used. I'm getting confused from the last problem, so we're good. We don't need to worry about the values that we are picking because there are no inverse functions in here. So I'm perfectly fine with square root of 3 over 2 divided by negative 1/2. Negative square root of 3 is in fact going to be the value of tan alpha. The value of tan beta is going to be 1 because pi over 4 tan is always going to be 1. I take those values and I plug them into this formula right here, and I will get an answer. Okay, cofunctions. These are actually pretty simple to explain. Let me clear this up. Imagine a right triangle, and this here is my right angle, and this here is my angle alpha. Well, what is this angle? Well, what's one property of a triangle? Well, the property of a triangle is that angle A plus angle B plus angle C up here should be equal to 180. Well, if angle A was 90 and then angle B is theta, what can I add here that will guarantee that I get 180 degrees? It's actually easier to look at this in terms of radians. Now, when I subtract 1/2 from both sides, I get pi over 2. Then I subtract theta from both sides, and that's exactly what this is, pi over 2 minus theta. This angle can usually and almost always be referred to as pi over 2 minus whatever this angle is. So if I know this angle here in radians, I can actually get this angle in radians, and that's what's known as a cofunction. If I have an angle here, I can actually use some of the same information as long as I change it up using this cofunction. So let's look at some identities. For example, a sine of theta could be also rewritten as cosine of pi over 2 minus theta. It could be this, if I use the sine, so if I have an angle here, so if I have an angle theta here, and I'm trying to find the sine value, which is opposite over hypotenuse, I could use the same angle up here, which is, I can use cosine, which is adjacent over hypotenuse, as long as I reference that angle, not this angle. I need to reference pi over 2 minus this angle, and that's what's written here. I can do the same thing with cosine as long as if I have an angle here and I'm trying to find its adjacent and hypotenuse, I can use sine. I could go down here and try to get this angle and go sine opposite hypotenuse, but this angle is therefore pi over 2 minus theta. So I could use cofunctions to alter where I'm trying to find my values in the right triangle. If I'm using sine, my values come from opposite hypotenuse. If I'm using cosine, they come from adjacent hypotenuse. So if I want to take the sine of a value of this angle, I could adjust to take the cosine as long as I use this formula to adjust this angle so that I'm taking the right angle for this part of my triangle. That's what's known as a cofunction identity. It's a relationship. Cotangent, secant, and cosecant, they all use the exact same formula. So we can use these cofunction identities that can kind of help us get information out of a triangle based on information that we have been given. And so, for example, what if we were to write tan pi over 9 in terms of its cofunction? Well, what is the cofunction of tan? The cofunction of tan is cotangent. So let's go ahead and clear that. So if I were to say that I wanted to find tan pi over 9 using its cofunction, which is cotangent, well, then I would take the formula for tangent for its cofunction, cotangent, pi over 2 minus the theta. Well, what is my angle? What is my theta? My angle was pi over 9. So that's going to be inserted into my theta value. And then I just need to subtract these two. So that's going to be, let's see, that's going to be 18. So I need to multiply this by 9. So that's going to be 9 times pi over 18. And then that's going to be 2 pi over 18, and that's going to be cotangent 7 pi over 18. So the cofunction, if I was to try to look up a triangle, and I was trying to get the tangent value of that angle pi over 9, I could use the cofunction for tangent, which is cotangent, as long as I adjust its angle using the property of cofunctions. So the tangent of pi over 9 is going to give me the same answer as the cotangent of 7 pi over 18. If that's what you needed to do to solve a problem, we can do that. In fact, I can take the cofunction of this value and I can get the tangent of that same angle, and I can go ahead and put that into a calculator. Or I can go ahead and use the properties of sine or tangent in order to split them up and get an exact answer. So we did that. Write sine of pi over 7 in terms of its cofunction. Again, the cofunction of sine is cosine. Pi over 2 minus, well, pi over 7. Simplify that, and you will get the cosine equivalent. And again, that will be, so whatever pi over 7 is, we take pi over 2 minus pi over 7. So pi over 2 minus pi over 7. So we multiply 7 here, so that's 7 pi over 14. 2 here, that's 2 pi over 14. That's going to be 5 pi over 14. So the cosine of 5 pi over 14 is equivalent to the sine of pi over 7. They are cofunctions. Now, an interesting thing is that we might be asking to verify an identities involving sine. Again, practice this by practicing what we learned in chapter 7.1 to verify that this, in fact, is equal to that. And once you find an identity, you might be able to use those identities later in math. You could probably write them down, and if a certain problem comes up, that identity might actually be useful. What else can we do here? So, we could finish off with this one word problem if you guys are so inclined to look at this one for just a quick second. So let's go ahead and look at this one, just so that you guys are capable of, also using these exact same ideas that we've just used and put them into use with a word problem. So we have this diagram, and we have been told that this wire from here to here, which is S, is attached at 40 feet on this pole, and it is 50 feet from the pole. The same wire is attached up here. That is attached at the part of the pole that's 47 feet up, but it's attached at the same 50 feet across. There is an angle that represents this wire R to the floor, and there is another angle that represents S from the wire to the floor, and there is another angle A that's between R and S, the angle that's represented between R and S. That is the angle that we want to find. So what information do we have, and how can I use it to find this angle? Well, here is a couple of things that we have. For example, I have tan of beta. What is tan of beta? Well, beta, as we've been told, is the angle from the floor to R. So that's going to be 47. It's the opposite divided by adjacent. So that's 47 over 50. Okay, that works. I also have this value. This is not beta. This is beta minus alpha. So I have tan of beta minus alpha, and that is equal to 40 over 50, or 4/5. And I need to find this little piece of information. Once I find this angle here, and once I find this angle, I take this value, which is 47 over 50, and I need to subtract it from whatever I find from this value here. Tan of b minus a is equal to 4/5. Now we know that this is equal to 4/5 because that's basically 40 divided by 50. So we need to start using some formulas in order for us to solve this. Because here's the problem. I need an angle. I need to know what beta is, and I need to know what a is. Because if I don't, well, I need to know what beta is, and I need to know what beta minus a is, because if I don't know any of those, I'm not going to be able to figure out what the angle is. I know what the value is, I just don't know what the angles are. So I'm going to go ahead and use the formula for tangent that's going to help me with this. So if I scroll up and I look for that identity, which is where? Right here. Oops, not there. Where is it? This one. Tangent of alpha minus beta. Now I have to be very careful because this is not this. So I need to make sure that I interchange a few things. So the tan of beta minus alpha is equal to tan beta minus tan alpha. Notice what I'm doing here. I'm being very careful because of what I've got written here. And that's going to be divided by 1 plus tan beta tan alpha. I have to switch these around, and I can do that. Excuse me. Now, do I have any information that will help me figure this one out? Let's go ahead and expand upon this. I do have tan beta, that's 45 over 50. So let's go ahead and plug a few things in. I do have tan beta, which is 45 over 50. I don't know what tan alpha is, so I'm going to write that down. 1 plus tan beta, 47 over 50. And that's going to be multiplied by tan alpha. And I do know that this is equal to 4 over 5. I need to solve for tan alpha. Well, this is why we take algebra. So how do we solve for that? Cross multiplication is going to be probably the best form of action here. So 5 times 47 over 50 minus tan alpha is equal to 4 times 1 plus 47 over 50 times tan alpha. All right, let's use the distribution formula. That's going to be 47 over 10 because these cancel out. That becomes 10. And this becomes minus 5 tan A. That's 4 plus whatever 4 times 47 is. I can bring a calculator out for now. Calculator. Let's do 47 times 4. And that is 188 over 50. And that's going to be tan A. I've got variables on both sides, so I need to move things around so that I have a variable on one side. So I'm going to subtract 4 from both sides here, and I'm going to add 5 tan A. Sorry, that's 88 to both sides. I'm going to factor out tan A there. 47 minus 10, well, that's just 40 over 10, so that's going to be 7/10. And that's going to be equal to 188 over 50 plus 5. And that's going to be all multiplied by tan A. I factored out tan alpha. I factored out tan alpha from that. I'm going to divide what this is. Well, this, if I multiply this by 50 over 50, that's 250 over 50. So let me just rewrite that. 250 over 50 plus 188 over 50. Well, that's 250 plus 188. That is 438. So 438 over 50. 7 over 10. Need more room. Oh, ran out of room. So let's move over here. I'm going to multiply. I'm going to divide both sides by 438 over 50. That's the same as just multiplying things by 50 over 438. And therefore, I have found my answer. Tan of alpha is equal to 350 over 4380. So 350 divided by 4380. And that's equal to 0.79. So tan A is equal to 0.79. Okay, so I have tan of beta is equal to 0.450, or 74, I'm sorry, 47 over 50, and tan alpha is equal to 0.079, well, 0.08. So how do I get the angle? Well, I could do an inverse function of 0.08, and that is a radian. So let's make sure that I'm in radians. And I can do an inverse function for tangent, and I will get 0.07. I'll get 0.08 again. So I have a radian angle A is equal to 0.08. And in order for me to get the actual angle, I need to use the formula that says that x over 180 is equal to y over pi. Well, I'm trying to get 2 degrees, so 0.08 over pi is equal to x over 180. So I need to multiply. That's not what I wanted to do. I need to multiply. Where's my calculator? Lost it. My calculator is 180 times 0.08. And that's going to be divided by pi, which is right here. And my answer is 4.6 degrees. So the answer is alpha is equal to 4.6 degrees. Lots of work. Lots of work in order to get through all of that. There's a lot of work that happened there. But it's necessary. It's necessary to get through all of that. So there we go. That is 7.2. Review at your leisure. Please review it because these are not the easiest things in the world to just do without studying them. We have to study them. We have to practice. You're good for the homework assignment. And if you have any questions, we can cover a few things tomorrow, and hopefully maybe the substitute that's there might be able to also help you out with some examples that we can practice so that we can get through this and start getting used to how this works, because this is a very theoretical part of trigonometry. All right.